Assalamualaikum warahmatullahi wabarakatuh. Here my name is Bakthi Ananda Harisona with NIM or student ID 24343085. Here I will explain for meeting 13 and meeting 14. For the This is a topic from Logic Mathematics in Informatics Universitas Negeri Padang. Okay then. In this presentation, there will be two main topic here. First, there will be mathematical induction and then sets. First, we will start with mathematical induction. Mathematical induction. What is it? A mathematical induction is one of the latest techniques that is developed that is used to testing a conjecture from that appears repeatedly and has a pattern on itself. Here are some example I put. Suppose there is 1 cent and 5 cent coins. And then suppose there is 3 cents that is newly released. Then in every amount of 8 cent, it can be represented as 3 cent and 5 cents. This is the simulation I put here. 8 is equal to 2 added by 5. 9 is equal to 3 added by 3 times, and so on and so on so on so on. Here is the formal written stuff. It is n greater or equal to 8, where n is 3 and or 5. The simulation here prove that Pn is true for all values and greater or equal than 8. In here, uh, I assume 8 is k, okay? Sorry, this is not 2, but it is 3, okay? 8 equal to 3 added by 5. We assume a as k, okay? Then 9 as k added by 1. K added by 1. Then we will notice a pattern here. First, there is 3 added by 5, but here in 9, uh, it is replaced by 3 added by 3 added by 3. And then again here, we have 5 added by 5, that is equal to 10. But then in the next simulation in 11 is equal to 3 added by 3 added by 5. Here we can notice a pattern. In the k, there is 3 added by 5, but then after the k plus 1 here came, 5 will be replaced as 3 added by 3. We can notice it as a pattern here. And I added it as a note in bottom. Okay. And then again, this is the step. Is pH is true. We can conclude that Pn is true if pH is true. And then for all the integers of k greater equal than a, if pk is true, then p k added by 1 is true. Here is some example I put. The question here is 1 added by 3 added by 3 and so on so on so on until added by n is equal to n times n plus 1 divided by 2. First, here are the first step here. We we will confirm if pH is true first. Then we will confirm here. 1 uh 1 here will be replaced by 1, replaced by 1 2. 1 times 1 plus 1 divided by 2 equals to 2 divided by 2. That will equal to 1, which is true. And then for the second step here, for all the integer of k greater equal than A. If pk is true, then pk plus 1 is also true. Here we do it. If pk added by 1 is true, assuming that pn is also true. Here we will use it. Pk is equal to this equation here, equal by k times k added by 1 divided by 2. Then we will replace it by k plus 1 here. K plus 1. Here we will also replace it by k plus 1 and add 1 also on the different side of the equation. Okay, we will then have this equation here. We will prove if this equal to this equation. And then here, this is 1, okay? Sorry for the mistype. We will have the same equation that is proving that this is true. Okay then. Uh, we of the next section here we have strong mathematical induction. What is the difference to the mathematical to the regular mathematical induction? Here in strong mathematical induction, uh, is basically the same as the ordinary version. That is a technique to determine the truth of an integer series that have two stages. But the but the equal is ended there. In here, in the how we determine it, it will be having a difference. In the first stage, there is basis stage, and then in the second stage, there is introduction stage. Uh, and then other than these stages, that is differentiate them from the regular mathematical induction. There is stage the truth to predict Pn is assume not only one value but for all values up to k. Okay, this is the continuation from this explanation. To show if for all np n is true or not is by these stages. First stage is basic stage, the same as this. Basic stage is to prove that P1, P2, P3, and so on until Pn are true. And then on the second stage is induction stage to show that P times by K plus 1 truth by the truth that is obtained in the basic stages. So it is basically the continuation of the basic stage, the same as the ordinary mathematical induction. Okay, here are some simple example that I have been put here. Here the question is to prove the integer that is greater than 1 is divisible by primes. Okay, it is primes, prime number. Uh, on the basic stage, we will prove this first to prove that here. Here we will take 2 is p2 equal by 2. Here 2 are satisfying the condition. It is divisible by prime numbers such as 1 and 2. This is true because 2 can divide it by 2 primes numbers such as 1 and 2. Okay, then we will continue to the second stage, that is induction stage. Induction stage, we will show for all integer that is k greater equal than 2. If pi is true for all I from 2 to k, then p times k plus 1 is also true. Then after letting k be, then after that, we will let k be any integer, where k is greater or equal to 2, and let I be divisible by prime numbers. For all series I from 2 to k, we must show that for k plus 1, it is divisible by prime numbers. Okay, to the next topic, we will have sets. First, what is it? What is set? Set is a collection of different objects. Object here can be referred as element members or the element of the set. This is the element that are not order. Notation of a set here, I write notation of a set is usually capitalized such as A, B, C, so on until Z. And then it is the notation of a set member, the member of a set that will be usually a lowercase, such as A, B, C until Z, that is in a lowercase written. Okay. In the next section, we will have sets notation. Here I have some symbol. This is a symbol that we use to represent X that is a member of A. And here, uh, in this symbol, we will just put a line on it to represent that is X is not a member of set A. And here is to represent that a set is empty and have no members at all. On, and again, n here is to represent natural numbers or a number that is going from 1 to infinity. And then is n0, that is a whole number. The difference is just from the natural numbers. It is just going from 1 to 0. So it is going from 0 to infinity. Okay, then we will then have sets of integer, set of integer here in the that represented by z or z plus. On particular here, these two symbol are representing two different set of integers. If we just represent it by using z, then it is going from minus infinity to infinity. But if we just using the z plus, then it will just mean it is representing the whole positive number. Okay, then we have key, or q is a set of rational number. Okay, then we will have set and its subset. Okay, here I I will explain what is a subset. But first, this is how I will explain it first. A equal to B. Remember here, if we're talking about set, and we have capitalize A and capitalize B, then we will be talking about set A and set B. If set A is equal to set B, this is usually how they represent if set A have the same element as set B. And this is how they represent if it isn't having the same element as it. And then, what is a subset? As this is it. If if all of the A elements is in set B, then A is a subset to B. Here are the notation on how we will represent it. A is a subset to B. And then again, if A is a subset to B, we will be able to call B as a superset to A. Okay, to the next section we go. We will be talking about universal set and Venn diagram. What is universal set? Universal set is the entire set of uh, that being considered the universal set in the node, and it is usually denoted by S or U. And then what is Venn diagram? Here we can see the example of a Venn diagram I put here. A Venn diagram is an illustration that illustrates the relation between a member of a set. Here, for example, we have set A and set B. set A have this element and set B have this element. But here, uh, these two set have the same uh, have the same element, have uh, have part of it the same element of each other. And here is how we write it formally. You can see it on how we write it formally. Okay, to the next section we go. We will talking about cardinality of finite set and equivalence of set. Uh, Here we will be talking about on how to count finite set and how is a set equivalent to each other. Okay. Um, what is it a finite set? A finite set is a set that has exactly n elements, where n is a non-negative integer. And then the cardinality or size of a set A is written like this: A or NA or sharp A. This is on how we write it, on how we write the cardinality of set A. Okay, and this is how we determine A and B as equivalent. Uh, let's assume we have set A and set B. Okay, set A and set B is equivalent to each other, written like this. If they have the same number of elements, then we will write it like this, the same as earlier. And this is also one of the symbol like this. The size of A is the same as the size of B. Okay, then we'll to the next section we go. Okay, to the last topic we will be talking about power set. A power set is like when A is a set, then the power set of A, or this is the notation on how we write but a power set of A to A. Uh, okay, power set is like when A is a set, then the power set of A is a set whose member are all subset of A. Example, okay? Here we go. For the example, A have a member of 1 and 2. And then we will write it as the power set of A is here, the same notation, equal to, mm, this is it is the notation of not having any elements. So it is included in the power set. This is the symbol we just encountered earlier here. Here in this symbol, the set is empty and have no member. So when writing a power set, this also included in it. Okay, even if it's having uh, a member in a set. Then we will go to 1, 2, and 1, 2. So we'll taking uh, any member of the set as in individual. Okay, I guess that is it. Thank you very much. My name is Bakthi Ananda Harisona. Thank you very much for host watching. Wassalamualaikum warahmatullahi wabarakatuh.